Welcome to the Technology Addicts podcast, powered by Avnet Abacus. Look around carefully, and you'll notice IoT technology impacting almost every facet of our lives. In urban environments, it governs street lighting, streamlines traffic flow, and enhances public safety by monitoring for criminal activity. Beyond cities, IoT technology can be found driving factory automation, optimizing farming by analyzing soil conditions, and even regulating your office climate. Within the devices, it's often the microprocessors, RF modules, and connectivity protocols behind their frontline functionality that get most attention. But there's just so much more to the story. Behind every successful IoT application, countless additional components need to interact perfectly without missing a beat to deliver flawless performance. In today's conversation, we're going to explore some of the IoT revolution's hidden heroes, crucial yet often overlooked components like crystal oscillators, antennas, and supercapacitors. Joining us is Carmen Redondo, Director of Global Marketing for Antennas at Kyocera AVX Components. Hi, Carmen. Welcome to the Technology Addicts podcast.
Thank you. Hello.
And also with us is Tim Basford, Technology Segment Manager EMEA for Sensors, Wireless, and IoT at Avnet Abacus. Hi, Tim. It's great to have you in the studio.
Hi, good morning, everyone.
So most of you already know Avnet Abacus and its role in the IoT space. But to kick off, Carmen, could you briefly introduce Kyocera AVX and tell us how it fits into the IoT ecosystem?
Yes, so in Kyocera AVX, we are manufacturing many different types of advanced electronic components, capacitors, filters, connectors, and of course, the superheroes that we are discussing in this podcast, which are the crystal oscillators, antennas, and supercapacitors. We cover a big range of applications from automotive to consumer to medical, but of course, we are very present in the IoT market, which there you can connect anything from a small cat to a meter to lighting. So IoT started years ago when it started becoming this term popular. And by then we saw even other technologies like Sigfox and LoRa was popular. And then we saw the operators start becoming more and more interested in this technology because, of course, until now they were selling SIM cards to people, but now they could realize that they could sell SIM cards to anything, right, that is connected. And I remember then there will start being many different type of ideas, from connected necklaces, from tiny cameras, even rings. And the customer comes, hey, I want to make this ring and I want to implement connect to the GPS and the cellular. And so there was very, very little knowledge. And this is one of the biggest challenges that happened in the beginning because projects will run for several years, a lot of proof of concepts. And unfortunately, we saw many customers failing in the process because they were very optimistic. They didn't really understand, what are the considerations that they come to us too late. And that was the main reason of failure. I think nowadays, in Kyocera AVX and I guess in other manufacturers, we have invested a lot of time in educating our customers. So sometimes more like presenting our products is training them to understand the awareness of what are the challenges they might face, why it is important, as Tim was saying, to come in the very beginning. And you will be surprised how today, still many customers, when I show them this graphic, how the performance of the antenna will vary depending on the PCB size, would be surprised like, oh, really? You lose so much performance by reducing few centimeters. So this is one of the purposes that we have. Also, the size can also affect other components like the super caps, depending what is the size, is depending the storage you can have. So the way that Kyocera AVX is fitting in this ecosystem is not only about educating our customers and having good partners like Avnet Abacus, that they also have the experience to educate, but we are investing a lot in making a lot of tools, a lot of reference designs with key partners, because having the customers starting from a good starting point will really predict a success in the future and faster time to market.
That's great. And I think this episode will also be very helpful in educating the customers even further on the importance and the benefits of reaching out early in the process. So, Tim, could you comment on the perceived hierarchy of components and technologies that go into IoT devices, from the most expensive parts down to the nuts and bolts that hold the devices together? And in your experience working with device manufacturers, does this have any impact on how they go about designing solutions and sourcing their parts?
Yeah. Okay. I think I'll start really at the beginning of an IoT journey. And when a customer comes to us, they generally have a kind of focus on a use case in mind, and their return on investment is to start delivering insights to their data and get a good kind of return on investment back from what they're doing. Many times we see customers using kind of expensive off-the-shelf hardware later on doesn't really scale. I think kind of Raspberry Pi. It's often an enterprise class kind of customer who are probably very involved at the software level and don't really have a good idea about hardware. So the proof of value is kind of achieved very easily with their off-the-shelf hardware. And then they have to figure out how to build some hardware, some costed hardware that will meet the ROI requirements. So obviously using something off the shelf is not always the best plan from a cost point of view. Generally speaking, I think some of the enterprise customers we deal with don't understand embedded electronics that well. And they're often very, very shocked by the considerable timescales and the costs required to build a scalable hardware solution. And as we know, IoT is all about scale. Without scale, you don't have a solution to your problem. So that's where Avnet Abacus comes in to help customers choose the right kind of hardware platform for their use case. This includes everything to build out the design from end to end in our case. For sure, we see customers, design teams focusing on the frontline components, often the kind of much hyped features of AI, machine learning, machine vision, secure OTA, all those kind of good buzzwords we hear in the industry nowadays. All this we can address as well within the Avnet organisation, but customers now need to think very carefully about the design challenges at the system level. And there are some clear gotchas, which some guys think about at the last minute and some guys think about during the project. So power profiling is an important issue. The requirements of the use case will govern the selection of appropriate battery and supercap technologies, and leaving this decision right until the end project. It's not good design practice. We need to understand what the customer's goal is there. They need to kind of understand how the physical side of things works as well. So, if the battery doesn't fit in the box, that's bad news. So Abacus and KVX can help the customer with trade-offs between battery and supercap, and we can arrive at the optimum solution. And often both supercap and batteries are used in conjunction together to provide, the supercap will be providing an extra piece of power or energy provided into a cellular device or something like that to give us an extra whack when the radio turns on to send messages. So in wireless antennas as well, we need to understand what kind of antenna the customer is looking for, what kind of application they're working with. Again, not a good practice to leave all this to the end. We see it a lot of times when the customer has a design functioning, they move to their final format, their kind of fixed mechanical design, and they find that the antenna is now an issue, or they haven't positioned the antenna in the right place. They need to understand more on how that works. So we've seen many, many customers where the antennas simply don't fit in the design enclosure, leaving this out, leading to a non-optimized solution that hits all sorts of other metrics of projects as well and reduces the kind of final chance of success. So Abacus and AVX can help with all that initial design review for the customer's physical antenna placement and obviously help the customer choose the absolute correct antenna for their design. So we've recently been working with a customer in an automotive router, for instance, where the customer came to us and said, we've got 2 LTE antennas in this box, we've got GNSS, we've got GPS, and we need to understand where to place these antennas. So we need to understand how the connectors in the box affect the antenna performance. So that's the kind of thing we get into at the front end of a design before the thing starts to go into production and issues are occurring. Obviously, certification is another big issue. Certification is not free and it's mandatory in a lot of spaces and can vary from region to region. And that's something that the customers also need to think about at the front end. It's expensive and can be time consuming and impact project timescales quite considerably if you miss your slot. AVX can recommend antennas that are pre-certified. This can help with the subsequent system level certification costs. We're quite often in that space where we were actually recommending pre-certified antennas. Some of the modules we have in our Abacus portfolio have pre-certified antennas which do not sort of get the customer past final product approval, but a good way to bootstrap the process. Cost of ownership is another big one, really. Different blend of careful component selection and technologies designing. Obviously, there's an optimized path for most of these things. Customers need to hit the ROI target, so they're not always able to use the most expensive hardware. So we will help them to hit that trade-off, hit the point where it gives them the best kind of bang for your buck. In summary, really, there's really many obstacles designing successful IoT products. And they're not just cheap pieces of hardware. When you need to scale it, this is where it becomes very, very important to get it right. You can't make 1 million devices and have issues. Throughout the design process, we kind of help customers uncover all the potential risks and highlight where we can help as soon as we can. So my recommendation to the customer would be to come and talk to us as early as possible, and we'll give you as much information and as much of our pretty wide, extensive knowledge that we've gathered over the years, helping customers do these kind of things.
So here we'll be focusing on crystal oscillators, antennas, and the supercaps you've already mentioned. Carmen, could you give us a concrete example of what roles each of these play in a typical connected device?
Absolutely. So let's start with the crystals. So the crystal oscillators generate clock signals, and they are like a kind of metronome in the electronic components. So they synchronize time-sensitive applications, and also they timestamp vehicle movements, enable real-time tracking. So many IoT applications are time-sensitive, such as the traffic systems or smart metering grids. For all of that, it's important to have high-quality oscillators. Then we talk about the supercapacitors. They are typically used if the power supply of an application doesn't provide enough lifetime or enough reliability over the lifetime. This is very important for the IoT devices, which they are tending to have a long battery life. Some examples, you can think of battery-powered device at very low temperatures. I think this is something that people that maybe go hiking with the cell phone and very low temperatures, they can see in the harsh winter, they can see how the battery life can be affected in these cases. They also the smart meters. Smart meters, when they usually have lifetimes by more than 10 years. So I think if it would be very difficult to achieve those levels with only batteries. However, we should not exclude the big power devices. So if you consider like an X-ray machine in a hospital placed in the country with poor grid, low power, low circuit breaker in the building, you want to ensure the functionality of the machine. So it's very important to have some backup, that we can get with the supercap. So in general, the supercapacitors can have different type of applications that they can help with. And then the last but not least, the antennas, the big forgotten component in the IoT devices. Many times I see that if you have a wireless device with an antenna, it won't be wireless. So it's quite important component there. But they are very underestimated. People think that, okay, now I've designed my whole device, I just place the antenna and that is work. Really, again, as I mentioned before, the awareness is very important, is where to place, depending the type of antenna. It's not the same an antenna for LTE, for Wi-Fi, for ultra-wideband. They all have different considerations, different requirements also in terms of performance. So very important. And of course, they are the opener to have good wireless devices.
Okay, so if we zoom in on the supercaps, what particular experience does Kyocera AVX have working with supercapacitors?
So if we define like a true supercapacitor as a low ESR high capacitance device, we actually start selling supercapacitors in 1997. So I will say we have only a few decades of experience at Kyocera AVX. At that time, it was one of our patents was named BestCap. We thought a lot about the performance of the supercapacitors and also gave us the chance to collect a lot of valuable long-term field data for this technology and learn to the products that we have now. Nowadays, these components is no longer in our portfolio, but we have others which are the cylindrical series of supercaps. So today, most of the big market for our supercapacitors are in the automotive, which really illustrates the level of quality that we bring to the table with our components.
So what are some common applications that rely on supercapacitors?
So this is a very common question. So we recognize 3 application types which could be represented in any market area. So we're seeing new market areas popping up, and sometimes even we are surprised by them. However, it's always, let's say, the type of application. So first, I will say the pulse power support, which provides your application with high energy bursts when needed, typically used together with batteries. When batteries is for a stable low power supply, and the supercaps kind of secure the peak energy demand situation. So if you will use only a battery for both functions, you will reduce this lifetime. And in some cases, the battery alone will not even be able to provide enough peak energy. So another application will be the power backup. So traditionally handled by batteries, but if, again, you use the supercaps, then you will provide a longer lifetime in your application. And the energy harvesting, which is very interesting application in the IoT. So you can successfully use supercaps to store the harvested energy under the condition that you constantly or you use regularly feeding. So this is connected to the fact that the supercaps have naturally higher leakage current than the batteries and will self-discharge if not fed properly. So as a benefit, it will again provide you with much longer lifetime and without maintenance compared to batteries. And I have a good example in the Wi-Fi sensors. There are many projects on Kyocera VX that we combine products. So in this case, you have antenna, you have the supercaps, In this case, you are able to provide the sensors for the forest in the very remote areas, and you get the energy from the solar panel. So in that case, it's a component which is environmental friendly because you don't have chemical batteries. You don't require the maintenance. And so it's a very, very good example to show how is the benefits of the supercaps in IoT.
All right, thank you. And how should a device manufacturer decide between integrating a battery or a supercap into their product?
Yeah, so this basically ties to the previous explanation. So if you require better performance from your power supply, it may be good to think about the supercaps. But in most cases, you will actually use both in parallel, which allow you to utilize advantages from each for the battery and from supercaps. So at Kyocera VX, we have developed a supercapacitor that sets itself apart from the competition for its very low ESR and its predictable decrease over lifetime. This allowed us to recommend supercapacitors will fit the customer's application needs and allowed you to operate successfully also until the end of the lifetime.
And Tim, how do you advise customers confronted with this decision? What are trade-offs that they need to consider?
Yeah, we generally would speak at an early stage about power profiling, as I discussed earlier. The customer needs to be able to articulate their energy duty cycle requirements in some detail and work with us to kind of reach an efficient solution. It's obviously, if it's a device that's switching on every 1% of its duty cycle, then maybe you can live with the battery. But if it's something else which requires a radio switching on and very low quiescent power for the sensor when it's asleep, then you have a very small battery and you have a supercapacitor which is trickling off the main power or even coming or trickling off a solar panel fed energy harvesting solution. So we typically see both supercap and batteries used to meet the technical and physical requirements. And also as well, commercially it's trade-off as well. Some battery technology is very expensive and some battery technology is just not appropriate for a particular type of sensor. So I would say, for example, if you've got a small NB-IoT cellular-based device that's running on super low standby current, like down at sort of 10 microamps or something less than that, maybe for running a permanently connected EDRX connection, you need to be able to switch the RF on and send data. So when you need to do that, you obviously need more power. So we would, in that situation, maybe talk to the customer about adding a supercap to provide that boost of energy, and which can then deliver the peak currents for the RF devices. But it is a very complex trade-off. It takes time to get to the solution. And again, we need to talk to people early about this because otherwise it turns into something we're considered bad design practice.
So Carmen, in the example you mentioned earlier, the crystal oscillator acted a bit like a metronome. Why is timing so important for IoT devices, and what are the challenges to achieving such precise timing?
Yes, so why is important the metronome? So they synchronize time-sensitive applications. So high-quality oscillators are getting more and more important as in IoT, as the system speeds and the complexity of those syntheses are increasing. We have more interconnected, more network systems that require accuracy in timing. The challenge for achieving this precise timing signal is good coordination of the crystalline raw material, fine ceramic package, and a custom IC chip, which we at Kyocera VX, we can control in-house and also with our partners. So we have more than 50 years of experience in timing devices, and we have, let's say, all the secrets to achieve these important features with thousands of different part numbers, having a range from 1.5 megahertz to 170 megahertz. And We also have different types, or low current consumption, low jitter, or low phase noise, and also a tight frequency tolerance types.
And are there any applications in which Kyocera AVX crystal oscillators are particularly present?
So let's take the smart meter energy grid as an example. So the synchronization is necessary to manage and control electricity generation, distribution, and consumption, enabling coordinated actions such as demand response systems, power grid monitoring, and a grid stability. Everything should be harmonized together with good, let's say, like metronomes. No, so we are very successful on that. It could also be applications where the long-term supplier and high quality matters. For example, digital factories automations where they need the parts with good repeatability of quality for over 10 years. Also, we are very successful in wearable devices, having wireless technology, since we have a very small case sizes with tight stability and tight stability.
And the last member of the trio of hidden heroes is the antenna, which is sometimes the most visible of the three components that we're exploring today. Carmen, what factors should IoT device developers consider when selecting an antenna?
So first of all, as Tim mentioned before, is to think of the antenna first. I think as soon as you get the project, you have to ask questions about, okay, what are the frequency I want to use, what technologies, in what countries. It's not the same if you have a device which you only want to operate in Europe, or you want to have also to be available in the US. How many antennas, because also the isolation between them, what's the size of the device, as we said before. So all of those are the key questions that we need to have into consideration. And just to give you a couple of practical examples of why those things are important. So there is some specification for the operators, depending the length of the device. So just few millimeters in the length of the device could move your device from being just an IoT device or just being a small form factor IoT device, just for a few millimeters. And that reflects in the specification 8 dBs difference. So when you have a very small device, just for a few millimeters, you can have 8 dBs of more margin to pass those specifications. Also, for example, the FPC plus cable antenna. So we are now talking about embedded antennas, but sometimes the customers just place a receptacle on the PCB and they place the antenna and the housing. I always say they're like false friends, because everybody thinks, oh, it's very easy. I just put the receptacle and then, I will manage. But in some cases, especially in IoT devices, which are very small, they just stick the antenna wherever space is available. And that is not good. Most of the times it's the wrong position. And also the cable is radiating, is catching noise. So it's actually very, very complicated type of antenna for IoT.
And does KAVX merely supply the antennas, or do you also support the customers in designing their devices?
So yeah, we support the customers. So we have prototyping and testing capabilities around the world. In the US, here in Europe, we have in Nice, the south of France, so we cover all the countries in Europe and of course in Asia, which is also important. Sometimes if a customer needs support from different locations, we can support them almost regionally. And there we don't only recommend first the customer what is the best antenna. They also have simulation files of our antenna. So if they want to simulate their cells, they can also test their cells in their devices. But the most important is the final validation. So when the device is radiating, it's not only the antenna. This is the first step. We test the antenna, how it's performing. But later is the whole device. This how much power it is receiving from the module, if it's any noise which is in the device. So all these if there are harmonics for the certification, those are the kind of value added that we can help the customer before they go to certification. We have found cases where, unexpected the products like, the solar panels could create harmonics that they shouldn't exist, or the grounding of the antenna is giving issues. And, this experience is what is really helping to go from having just an IoT device, and if you are unlucky, you will fail, or to be able to overcome these issues based on this experience.
So there's really huge value in having an experienced partner guide you
Absolutely.
through the process. Yeah. And to both of you, now that we've explored the roles of crystal oscillators, antennas, and supercapacitors in connected solutions, what big picture recommendations would you give listeners interested in designing an IoT device?
The biggest advice is consider these key components first. As we mentioned in many times, as soon as you have the preliminary form factor, like X and Y and height, as long as you know what module you're going to use, what frequency you're going to use, and what is the user case that you want to have, that's the right moment to consider oscillators, antennas, and supercapacitors.
I absolutely agree. Customers need to come to us early in the design cycle to make sure that we don't fall down here, the gotchas, the holes that potentially kill an IoT project. IoT is absolutely all about scale, and leaving anything to chance is not a good plan. We've seen quite a lot of customers missing their ROI targets because the IoT hardware is literally just not cheap enough. The business plan, the business outcome, the whole thing doesn't fly. So come to us early and we will try and help you get to those costed solutions very efficiently.
All right, thanks. So it's really important to start with scale in mind. Be optimistic from the get-go and try to achieve those large numbers and design your devices so that it works. So at the end of each episode of the Technology Addicts podcast, we ask our guests the same question. What would you say is your current technology addiction? It could be anything from a gadget that you recently bought to an entire field of technology that's captivated you. Carmen, let's start with you.
So something that, it's a technology that we work on it, and I think it's not as popular as when people are talking about 5G or IoT in general, which is the ultra-wideband. So we are doing a lot of work in ultra-wideband, and for me, it fascinates me because of the application it has. It has very accuracy, it's of distance in terms of centimeters only. And, you can apply it for indoor location, broadcasting, security. And we see a lot of, more and more applications and projects that we are doing in automotive and in the laptop market. But, the amount of applications that it could be, is also, for example, used in soccer. In soccer with ultra-wideband, you are able to see real time all the position of the players. You can get the analytics from them. You can even predict future injuries of the players. So we have customers, when we work with them, we learn all these things. I saw demos. And for me, it's really an absolutely technology that I hope goes faster than it is, because there is so many applications that still people don't even think about.
No, it's fascinating. Tim, what about you?
Mine's a little bit more personally focused. I've been in this technology business for a long time, as you can probably tell. My kind of really personal interest is vintage guitars, electric guitars especially. So I quite like the melding of vintage guitars with extremely modern DSP-based amplifier and effect technology. So it's and kind of home recording systems. So that's kind of how I get my kicks, if you like. But yeah.
We should ask you to play a intro jingle on the electric guitar. That'd be great.
Play you out. Yeah.
Okay, so with that, I'd like to thank Carmen and Tim for joining us for this episode of the Technology Addicts podcast. Dear listeners, if you'd like to get in touch with Carmen or Tim, you can reach out to them. You'll find all the contact information in the show notes. And to everyone listening, thank you so much for joining us today, and stay tuned for the next episode of the Technology Addicts.